Alrighty, so now we're going to look at how you write a sine and cosine function from a given graph. So it's a little bit different than graphing, a little bit different but very similar. So in this particular example, I would look at what you're given and kind of decide what you have to start with. So in this case, I have an inverted sine. So I'm just going to kind of take a little bit of a inventory up here. So I have an inverted sine graph. And if you look, I know the max value is -9 and the min value is -15. So I need to find the average to get my center line. So the difference here is 6. 6 divided by 2 is 3. So I would add 3 all the way down here to get -12. So you would do the average of your max and min, so -9 plus -15 divided by 2 would be -24 divided by 2, or -12. So this is going to be your D value. So your D value is -12. The original graph is an inverted sine. And my amplitude here would be 3. So A will be plus or minus 3 depending on how I'm writing my sine or cosine. There are an infinite number of ways that I can write the function here, because remember, this is an sinusoidal, so it's going on forever in each direction, and that's just something really important for us to remember. This is my starting value, and this is my end value. So to find the period, you can always do end value minus start value. Okay, so in this case, it's going to be pi minus the -pi/5. So subtract a negative, we add. I need a common denominator. So here I'm going to get 5pi/5 plus pi/5 equals 6pi/5. And that's my period. Okay, but that doesn't tell me B. So now the period, which is 6pi/5, will equal 2pi/b. And now I can cross multiply to solve that out. So you're going to get 6pi times b equals 10pi when I do my cross products. And to solve for b, I divide each side by 6pi. Okay, that's a lot of work. The pi's cancel, and I get 10/6. So therefore, b is 5/3. And once you find b, it will not change. So we've done 3 out of 4 things in terms of the variables. And now we have to kind of think through what is our phase shift. So for this problem here, the phase shift was -pi/5. So I have -pi/5, and that will equal -c/b. Okay, so when you have that, now I'm going to do cross multiplication, and I'm going to go a little to the right because I definitely am going to need this workspace below. And I have -pi times b equals -5c. And we knew that this was 5/3, so I'm going to actually go back a step and make that 5/3. Sorry, so let's fix that. So I have -pi/5 equals -3c/5. I knew something was wrong because I shouldn't have 2 variables. Now I'm going to cross multiply, and I get -5pi equals -15c. So then I'm going to divide each side by -15. And those all cancel, and then c will equal pi/3. So for the first one, I can say f of t, or f of x, whatever you want to say, equals. Now this was an inverted sine. I said that way up at the beginning. So therefore, a is going to be negative. So I have -3 times the sine. And now b was 5/3. Do not forget your variable. So I chose the variable t, so I have to have the variable there. Plus pi over 3. And remember in the last video, we talked about that the phase shift is not negative pi over 3. So we actually have to go through and do our math to figure that out, minus 12. And that is one way to write our sine function. And then at the very beginning, at the top of this page, it says write both a sine and cosine function for the graph. So that's where this is kind of challenging, because now I have to do this again, and I need to do that for a cosine. So you have kind of two options. You could either do your cosine here or your cosine there. But if you look through, oh no, I don't have my key x values, so I will need to find those. So remember, you find that by determining your interval. So I'm going to squeeze that in over here. So the interval, remember, is always the period divided by 4. Okay, so the period was 6 pi over 5 divided by 4. So that will be 6 pi over 5 times 1/4, and those will reduce. So this is going to be 3 over 2. So this is a not nice period or interval. So this is not a nice interval. So the interval here will be 3 pi over 10. All right, once I know that, I would make this so I had a common denominator. So I would change this to negative 2 pi over 10. And then I would add the 3 pi over 10 along the way. So I'm going to add 3 pi over 10, and that'll give me pi over 10. And then I'm going to add 3 pi over 10, and that will give me 4 pi over 10, which reduces to 2 pi over 5, plus 3 pi over 10, which is going to give me 7 pi over 10, plus 3 pi over 10 gives me 10 pi over 10, which is the pi. So I always like to see it through and make sure that those values work. All right, so now I'm going to pick an inverted cosine and do here. So I picked inverted cosine. So my phase shift, remember, is negative c over b, and I'm going to say it equals pi over 10. So here that would be negative c over, we said b was 5/3, equals pi over 10. So I could do that by saying negative 3c over 5 equals pi over 10, and then cross multiplying. So I get negative 30c equals 5t. And now I'm going to divide each side by the negative 30 to get negative pi over 6 for c. All right, and now I would kind of do the same thing. So I'm going to say g of t equals negative 3 times the cosine. And b was the 5/3 t. C is negative pi over 6, and I have minus 12. Okay, another way that I could do this whole process is by using the factor method. So if I use the factor method at the beginning, I could have said g of t, so this is an or. I could say g of t equals negative 3 times the cosine. I would have the 5/3 in front. I would have the t, and I'm going to say minus pi over 10, and then the minus 12 goes at the end. So it's always opposite. So if you looked here, we had pi over 10. So that's why this is going to be negative. You always switch it. And then if you multiply that out, it's actually not that bad. You have negative 3 times the cosine of 5/3 t minus pi over 6 minus 12. And that's the same thing that I just had here. So these are equivalent. I could have done this as a regular cosine, and said that the phase shift was 7 over 10. So let me show you another equation here. So I'm going to call this h of t equals, now the 3 is going to be positive because it's not inverted. I have my cosine. I'm going to try to write really small here, and I have 5/3 t, 5/3, and then my parentheses t, but I wanted to start at a positive 7 pi over 10, so this is going to be negative 7 pi over 10. minus 12. So instead of doing the work with a proportion like I did over here, I could just distribute, and I get h of t equals 3 times the cosine of 5/3 t. Here, the 5 and the 10 reduce to 1 over 2, and I get negative 7 pi over 6 minus 12. So this is another equation for the cosine that is perfectly correct. It's not asking for you to write more than one sine and more than one cosine, but there are lots of ways that I could have done this. If I wanted to go back here, I could have done an inverted cosine from there. I could have done a sine function that's regular and not inverted, starting at the 2 pi over 5. I could do an inverted sine starting at the pi. So there is an unlimited number of correct equations. However, there are some that are very common. So I showed you how you could get g of t a couple of different ways. And then this is h of t. So this was a regular cosine, not inverted. All right, I know this is a tricky topic. The more practice you do, the better you get at it. Hang in there, guys. Hope this helps.